Imagine if we had one board, one circuit board that we could take out of one of these robots and put into another. Imagine if this board was universal enough to power robots with N20 motors, robots with servos, even robots with both. It was so universal that it could power LEDs or buzzers as well. And this is the big one, imagine if it was future-proof because it already had I2C on reserve. Imagine no longer. Let me introduce you to minicore. Let's zoom in here and I'll show you what we're working with. It takes one ESP32-C3 SuperMini, one DRV8833, one boost converter. That's to step the single cell LiPo up to 5 volts so we can drive servos, and one capacitor for good luck. And the capacitor is the only thing soldered onto this board. And what about these male pins? What are they for? This row can power up to 2 N20 motors, but if you do, you lose ports 5 and 6. What do I mean when I say port? I'm calling these 6 rows of 3 pins ports because of how versatile they are. Each one can be used to power a servo, an LED, or a buzzer. Why 6? The chip pick 6. This ESP32-C3 has exactly 6 pulse width modulator channels. And PWM is the thing that dims an LED, holds a servo at an angle, and makes a buzzer buzz. It's the whole reason a port is a port. 6 channels, 6 ports. Which is also why the motors take port 5 and 6 off you. Look at where the DRV8833 plugs in. It doesn't have any secret pins. It takes from the port field, same as everything else, and it eats 2 ports. And it goes both ways. Building something with no N20s, pull the driver out. So you can power up to 6 servos or up to 2 N20s and 4 servos, all with one board. Or you can swap a servo for an LED or a buzzer. One more thing about these ports. Because I wanted to be able to plug all 6 servos into these ports, everything else on this board is the standard 2.54 spacing. But a standard servo plug is about 2.8. So I had to space the ports 3 millimeters apart for maximum flexibility. In a compact size, we could plug in all 6 servos. But as a result of not being standard, that breadboard trick that I showed you earlier will not work. Because a breadboard expects 2.54 spacing, not the 3 that we're using on these ports. But remember, we have the jig that goes along with this board. Print the jig, and it will hold all of the pins for you for when you go to solder. So we give up the standard spacing for maximum flexibility. One more thing the chip decided for me, and it's my favorite. These 2 pins here are the serial pins, and every time this chip resets, it dumps a load of boot chatter out of one of them. Put a servo on that pin, and it twitches every single time you switch the robot on. So look where those 2 pins ended up. They're the 2 lines going into the motor driver, the direction lines. Because a direction line can't move anything on its own. If the speed is 0, direction is just an opinion. The 2 pins with the problem got the 2 jobs that don't care. the 5 volts going to these 6 ports never goes anywhere near the brain. A servo that jams pulls about an amp, and I don't want that amp anywhere near the brain's traces. So the ESP32 runs straight off the battery instead into its own regulator, which means as the cell goes flat, this robot dims. It doesn't reset. And remember, that capacitor, I said it was for good luck. It's not for good luck. It sits right across the battery, underneath the motor driver. And it's the fix for the thing that gets absolutely everybody. The robot that reboots the second it drives into a wall. A motor stalling is a step change in current. And a battery that's 3 connectors and a switch away can't deliver a step. A capacitor a centimeter away can. Now, remember when I said that was your budget? I lied. Because there's one more row of pins on this board. And right now, on this robot, they do absolutely nothing. This is the room we give ourselves to grow. I don't know about you, but I like knowing that the things I design have the potential to be more than I need them to be today. These 6 pins are power and I2C. Together, which means one minicore can power a second minicore and talk to it down one cable. What I'm showing here is a game of Marco Polo where the first board chooses a random number and blinks that random number, and the second board blinks that number -1. So this is just proving that one board can power another board, and one board can communicate with another board. So the budget we just went over, double it. Now you might be thinking, we've already got ESP now. We did that last episode. Why would we ever run a wire? Because there's one radio in this thing, and it does one job at a time. The second I need that radio for something else, a controller, a phone, something I haven't built yet, the radio's busy. This wire doesn't care. It's still there. That's the whole point of these 6 pins. They do nothing today. They mean I've got options tomorrow. So if you're wondering where you can get one of these mini cores, I'd check minirobo.io. See you next time. Let's build something.